Crash Course Instrumentation, Episode 26, Splices, Crimps, and Permanent Connections. Welcome to Episode 26 of Crash Course Instrumentation. This is the second episode in our series on conductors and electrical connections. In Episode 25, we explored how current flows, why continuity matters, and what impacts resistance at the microscopic level. Now we're moving from theory to real-world techniques for joining conductors in a permanent way. In this episode, you'll learn why a good mechanical and electrical bond is critical to connection reliability. We break down how proper connections need both strength and conductivity. A mechanically secure joint resists vibration and movement, while strong electrical contact ensures minimal resistance and heat buildup. This balance is essential for long-term durability and signal integrity, especially in industrial and mobile environments. How to make solid splices, from the classic Western Union twist to modern pigtail methods. The Western Union splice, known for its tensile strength, is ideal for long, unsupported wire runs or high-vibration environments. Pigtail splices are quick and common for junction boxes and residential use. We'll compare the mechanical properties and typical use cases of both. When to use solder versus crimp terminals. Soldered connections provide low resistance and high conductivity, but they can become brittle and fail over time under mechanical stress. Crimped terminals, when done correctly, form gas-tight connections that resist corrosion and flex. We'll explain how the application environment influences which method is better suited. How to select the right crimp type, ring, fork, butt splice, ferrule, and match it to wire size. Crimp terminals must match both the conductor size and application. Ring terminals offer maximum contact security, while fork terminals provide convenience for screw-type terminations. Butt splices connect two conductors in line, and ferrules maintain conductor shape for terminal blocks. We'll explain how to read crimp packaging and properly strip and insert wires. Why ferrules are essential for landing stranded wire in terminal blocks. Without ferrules, stranded wire can deform or splay, reducing contact area and increasing resistance. Ferrules compress the strands into a unified body, improving consistency and preventing long-term failures, especially in high-vibration or maintenance-prone environments. We also cover common mistakes. Overstripping can expose bare conductor and increase the chance of short circuits. Cold solder joints occur when heat isn't applied long enough to bond the metals. Crimps using pliers instead of proper tools often result in weak or intermittent connections. Why not all crimps are created equal? A good crimp forms a gas-tight seal by deforming both the terminal and the wire strands. Inconsistent pressure leads to air gaps, corrosion, and heat buildup. Ratcheting crimp tools apply calibrated force every time, ensuring a reliable and repeatable connection. Unlike cheap crimpers or improvised tools. Heat shrink versus insulation sleeves. Heat shrink tubing provides a tight seal against moisture, mechanical strain, and vibration when shrunk properly. Insulation sleeves, while easier to apply, mainly offer abrasion protection and mechanical support without sealing out moisture. Real-world focus. Industry best practices for panel wiring and field terminations. Best practices include using torque screwdrivers to ensure proper terminal pressure, labeling wires for clarity and maintenance, and testing insulation resistance before power-up. Ferrules and crimped lugs are standard in control panel work due to their reliability. Examples of good and bad connections. Good connections have smooth insulation transitions, no exposed conductor, and uniform crimps or solder joints. Bad connections often show frayed strands, excessive exposed wire, or uneven compression, indicators of future failures. What UL and IEC standards say about conductor terminations. UL 486AB covers wire connectors and solderless terminals, emphasizing crimp quality, insulation clearance, and secure mechanical performance. IEC 60999 covers screw-type terminal blocks and the need for reliable contact force and compatibility with ferrules. Whether you're wiring a junction box, fabricating control panels, or learning to inspect your own work, this episode gives you the foundational knowledge to make durable, low-resistance connections that meet industry standards. Watch all episodes. www.youtube at Crash Course Instrumentation. Join the conversation. https://www.facebook.com/groups 1725429047541. All instructional models used are courtesy of Tony Coupalt and the open source model project at tp/ibiblio.org, Coupalt, Socratic, Model Index, TML.